I was supposed to start recording before, but okay. So let's recap it again so that I can record it too. So assembly, as I mentioned, assembly, we can only say assembly when we have more than one part. As soon as we add two parts in anything, it becomes assembly. Assembly environment. So SolidWorks has three different types of environment. We saw that already. Part we are working for last so many weeks. Now we will be working on assembly. And the third one is drawing. Okay, so in SolidWorks, when we create an assembly, so we go there, part, new, and this is your option, part, assembly, and drawings. So from now on, we will be working on assemblies. Okay. And as you have noticed before, as soon as we start creating assembly and open up a new assembly environment, it brings in the files which are available on your computer. Whether they're open or not, they will always bring in a list. You need one, you click on it. If you say, no, I don't need any, I have to create more, or this is not the list which I need for, you can cancel it, and you can always bring it back from your computer, your USB, anywhere, download by using the instant components. Okay, so let's exit first. So this is your begin assembly because it is by default. I will exit. The assembly again, it has its own options. Like you want to change the sheet sizes, you want to change the standards, you want to change the dimensions. Everything is available under system options. Again, saying, we have the problem of snapping, we have the problem of, why it's not highlighting the lines or the sketching. It's all there. Exactly same as we have in the part, it is available in the assembly too. So under system option or document. Normally, especially for this course, I would say you do not need to change much other than this. Units. Okay, units will always be, when you will get an assignment, you will have a unit. Oh, it is MMGS or IPS. Okay, and you select accordingly. One of the add-on into the assembly environment is this assembly tab there. If it is by default, if it's not available, you can go into right-click on the toolbar, select the toolbars, go to assembly and click it on or off. I think I don't need markup, so let's get rid of markup. So in this toolbar, right-click, go to tabs. I don't need markup. I don't need add-ins. I don't need simulation. I don't need MBD, SolidWorks CAM. In this one, I just need really basically assemblies, layers, sketches, if I want to create any sketches. Why do we need sketches in the assembly? Let's say we want to make something, but we could not. Now we want to figure out, hey, I want to make a center line on a part, which will mate with an axis. So I can do that right in the assembly environment. We can create a line on a part and then use that to mate. It has all the features of sketching in these. Okay, so while I'm working on it, I would say you open up your assembly environment so that you can get familiar with it. Okay, so let's bring in some of the parts, and this is just for review a couple commands. So under assembly, let's bring some components, and you can bring in only one at a time, or you can bring it as many as you want. Okay, so I bring in three parts. I just want to show you, or I would say, let's review some of the commands which are available, or the mouse tricks which you will need. Again, the scroll button, moving in and out. Press the scroll. It is turning the whole environment. Everything turns or rotate. If you just hold the scroll wheel, or the center button, what they call from the mouse. Control, scroll, left, right, up, down. but it is moving everything together. Every part of that assembly is moving together. Well, let's say I want to just move the pin. How do we do it? So pin, you click on it, and then you control, let's copy. Okay, so if you so now, we need to, if you look at this assembly design intent, we are looking to fit this pin in this hole. Okay, but the pin is not in the right orientation. It should be vertical, then it will be easily, we can bring it in and start creating the base. So to move the individual parts only, you select the part, control, right button, and you can move it in any direction you want. Okay, if you, other way, move with triad, that is the very important part or important command. You can use that to move it into any direction you want. The 3D assembly environment is more complicated than the part environment because you are dealing really in the 3D space. All the parts could be in any direction, and when you try to move it, sometimes it's not very easy to see which way or which direction. Okay, but for now, just the commands: scroll, whole environment, control, center wheel, everything up and down or move. You select, control, so right click, you can rotate. And if you want to make multiple copies of it, let's say we have an assembly, we have a screw, we want 20 of those, all you can do is hold the control, select, and drag, and it will create a copy for you. Okay? Let's say we have 20 screws which we want to install in there, but all you need is bring in one, and then you just control, select, and drag. That will be a copy one way, or you can click there, control, and bring in from the feature tree. Okay, so I think, if you go to your, I have a couple notes, I'll send you those via email. There's like shortcuts and commands, how you use the buttons and, control or shift features. But just for, it makes the work faster. Do you really need to know it? Yes and no, because you can still make it work. Okay, click on there, move it, try it. Always remember this. Oh, this is already fixed, that's why. Okay, so those are a few little tricks to move, to rotate, or manage the assembly. Okay, you can select any part, delete. So what they call drag right will select a part. So that is the window. So you drag your cursor right, and it will select the part, and you can delete it. Same way as anything got deleted. The only thing, the difference, if you right drag, you have to select the whole component to do anything with it. If you left drag, the drag window, if it touches to any component, it will select it complete. Okay, so let's see the difference. So if I drag right, it is not selecting it. I have to have this enclosed completely in the window to select it. But if I do it left, it's selecting even if it touches the part which we are trying to target. Okay, these are little tricks. There are a lot of information on the internet about it, and as you practice more, you will learn. Are they necessary for this course assignment? Not really. You can make the work the ordinary way. You can select, try it, move, turn, which may take a little longer, but that's all you need for this course. Okay, so the basics of assembly, as I mentioned before, 6 degrees of freedom, 3 mates. Some, when you control the axis, it controls more than one direction in one shot. So you may need only 2 mates, but your indicator is, if you look at the right, so let me bring your part in, insert component, let's say assemble square, I'll just leave it here, I'll make it float. So if you do not have any mates, you can move the part anyway, which means it is not fully defined. The indicator for that is the negative sign in front of those parts. If your part is free to move in any of those degrees of freedom, it is not fully defined. Unless you required it to be free float up to a certain extent. Let's say you made a flange, you made a steering wheel. Let's say you made a car design and you made a steering wheel. Okay? You do not want it to move up and down. You do not want it to move left and right, but you want it to move or rotate around at least one axis. So in that case, you can leave that axis floating. Okay? Because that's the design. Okay, this one is your fix and float. When you bring in the part into the assembly environment, especially the first one, it automatically locks the part wherever you drop. Okay, it will be fixed. Once the part is determined as fixed, you cannot move it. So right now it is floating. If I turn the fix on, I won't be able to move it. So your first action should be, when you bring in a part, you want to make it orient to your design intent. So let's say, we talked about the marker example. I think everyone knows about it, what I'm saying now. If I want the barrel to stand up, you want your base part to follow that design intent. And you can do it, either you bring it in and you say rotate x-axis, rotate along y-axis, rotate along z-axis. You can use those commands, or you can drop it in, make it float, and then you can say move it with triad, or use the shortcuts with the control, the buttons with the mouse, and move it into the orientation which you need. That is your step 1. Then you want to make it align and fix really to the assembly environment origin around it. Again, we want to follow the origin, and you want to make sure your first part is fixed and fully defined by attaching it to the various faces or various planes, or the origin depends on what is your design intent. Okay, and it all depends on what is your design. Okay, so right now it is floating. I can move it anywhere. So let's make it fixed, but I want to make it fixed. Oh no, this is not my base part. Okay, let's do a very quick, again, make an assembly, insert components, and I will do this just on me. Then we have all those parts which you have downloaded from the eConestoga, and we will do that. Okay, I want assemble base. Okay, so I bring this part. I have 2 parts already made. One is the pin, one is the square block. So what we are going to do, we are going to make this, fixed first and properly oriented. Then we are going to bring in the pin and install it in. Then we are going to bring a square and install it there. And then during that course, we will learn the different mates. Okay, so mates are the tools which make them fully defined and connect to the other parts to convert a valid assembly. Okay, I will drop it anywhere. Let's say I drop it here, and this is fixed. And automatically, if you look at that part, it is also showing mates. There is no mates generated so far. What happens as soon as I brought in the part, drop it in, it fixed to wherever it is. Okay, so let's break it first so that we can put it into origin. Right click, float. Now I can move it. If I change it to fix, I cannot move it. Okay, so right click, float. And now let's made it to, last time the barrel, we made it to the different faces. I think when I design it, I have the origin here, right in the center. As you would do if it's a rectangle or a square part. So the one way, which is the faster way to align it to the origin, is create a mate between the origins. So here's your mate. This is your mate command. We click on the mate, and as soon as you click on it, this window is to select which faces you want to mate. If you want to mate planes, axis to a plane, plane to a face, origin to origin, circle to a circle. We have unlimited options really, which are given here. These are the standard mates, which are part of this course. Okay, then we have advanced mates, cams and angles and springs and everything, which are available in the higher level, of course. We are not going there for this one. Okay, so let's mate it to the origin and see what happens. So when you make mates, you can either select here or you can select from your feature manager. This first portion up to here is your assembly environment. If you look at this as assembly 3, this is all about assembly, and underneath is your part details. And if you look at the part details, it has everything in it. I did the boss first, then I cut a hole, then I cut a square in it. So it has all the details which are available under that part. If I want to change something, I can change it here, but that's not very important. Okay, let's see origin to origin, what it does. Okay, because the origin is right in the center, and my origin, is in the assembly origin is there. So if we do that, and there is two things, align axes or not. What that means is, when I say align axis, the Y of the assembly will align with the Y of the part. X of the assembly will align with the X of the part, so as the Z. Okay, if I do not want the axis to be aligned, I just want it aligned with the origin, which means I still want to move it, then I will uncheck that box here. But most of the time when you are thinking a design, you're always thinking ahead, so that when you go to the assembly, how they will mate together. Okay, so let's keep it aligned axes, origin to origin, click. It's still, because the mate command, the way it works, you can keep going. You created a mate, yes, it will be available to create the next one. You have to say yes to get out of it. Okay, when you say I'm done mating, I'm out of it. Okay, so if we look at this now, this is my 3D view, and it is, I can't move it anyway. It is fully defined. It's not fixed, but it is fully defined because there is no negative sign on it. Okay? Fixed can be anything. You can have a part which is fixed, but not fully defined. Okay? Goal is make them fully defined. Okay, so that's one. So bring in more parts, insert components. Let's bring in the pin. Okay, so now this pin needs to fit in that hole. That's obvious just by looking at it. And now I know this is not the right orientation. Two ways to do it. I can rotate it before dropping it in the assembly, or I can drop it in the assembly and then right click and say move with the triad and turn it around. Okay, so let's do the first thing. Right click. So you will have options. Rotate X, Y, Z, 90 degrees every time. If you look at this origin, I want this pin to stand up, which means I will be rotating it around X-axis. Okay, if I want to rotate it this way, I'm rotating it around Y. If I want to rotate it this way, this way, like this, I will be rotating it around Z-axis. Just look at this and see which way you need to rotate it. But again, you can just do what they call trial methods. Okay? Oh, this is not right, or this is right, or this is right. Okay? So there's no that if you do not do it right, it's gonna be you can't do the get the second chance. It is available. Okay? Hit and trial, what they call try and hit and trial method. Click on it, see if it moves to the right position. Okay? Trial and error. Okay? Yeah. Once it's there, I have this in. Now we have to bring it here in the center. So now let's look at the type of maze. Okay, so for circular components, if it's a circle to circle, what do you think the best assembly, what they call, design intent should be or could be? Concentric. That's the one thing. You have two pieces, circular, and you want to make them together. One of the options would be concentric or coaxial. What is the other one? So coaxial or concentric. Okay? You can also make face to face. So this face we can make with this face. Okay? Or we can do axis to axis. Okay, so let's look at both. Okay, let's do the axis first. We know already how to visualize the temporary axis. So now I can see this axis and this axis. So let's select those two axes. 1 and 2. SolidWorks is very, very smart. Okay? It knows when you select the two axes, you are looking for coincident. Coincident, axis over axis or point over point. Okay? So that is the one type of maze. Okay, I'm not going to use that. If I exit, it's going to go back to its position. The second option is, I don't have axes. Let's say I don't have axes. What do? I have these faces. Let's try the facing. Right? Make face, so you can see on the left, the face is selected, and this face. Now, you see, it's not coincident, but it is concentric. Okay, there's a slight difference between the two bores. You can define them twice, in two different ways. Coaxial or concentric. They are more or less same thing, but their technical definitions are slightly different. Okay? If you do not have axis, you can use faces to be concentric. Or if you have axes, you can say these are coincident. Okay, so let's do the concentric. Okay, now I cannot move it in any other way, but I can move it up and down, and I can also rotate it. It is totally, there's no feature which can tell whether it's rotating or no. It is, but if you, let's make it a quick feature so that you can see it. And you see, I did a whole save it. When I go to assembly, assembly is gonna assembly is going to say model contained, the assembly have changed. Would you like to rebuild the assembly now? Yes. Oh, the pin is at the bottom. Okay, so that's how SolidWorks works. If you change anything, it will take that change throughout the environment wherever that part has been used. Okay, so now I just move it up and down, and now you can see it's still rotating. Okay, so I have contained one transitional, too translational, but I still have really the 4 degrees of freedom available. Okay, so that is our first type of mating or mates, concentric or coaxial. You can use any if you have axes. So let's say now if you have a hole and a bolt, you'll be using coaxial or concentric or coincident. Okay, so that is one type. Now, I want this not to be fully in, but so that this pin should be out from this face by, let's say, 1 inch. Okay, so that is the second type of mate, which is a distance. Okay, so let's look at that. Mate, top of the face or the pin, and this face. It is automatically going to take coincident. They are both same, but I don't want it same because it's protruding outward on that side, but I wanted 1 inch on this side. Okay, so what we do, if you look at their option, they are parallel, which they are already. They could be perpendicular. As soon as I say perpendicular, it's going to say, nah, I can't do that because I already have a mate. Let's do that so that you can understand. Okay, because I said these two faces should be perpendicular. What that means, that pin has to sit like this, horizontal. So what is the SOLIDWORKS is telling you? The selected mate could not be successfully created because we already have those two faces concentric. We already told that this hole and this pin has to be like this. But the second command, we want that this face should be perpendicular to that face. So what is SOLIDWORKS is suggesting? Add this mate and break other mates to satisfy it. So add this mate and break everything else, or add this mate and over-define the assembly. Okay, this is a very good example, so let's see it. So add this mate and over-define the assembly. As I said it, a lot of things go right. Okay, we're telling us something is not right. How do we fix that? So here's how you see what mates are in that assembly or that part. Under this pin, we have these two mates, concentric or perpendicular. Okay, they both cannot exist together because for the first one, this is the condition. Second one, this is the condition. They both cannot exist at the same time. So what we do, we need to delete one. Okay, so let's delete the concentric one first. And deleting is you click, right click, and delete. Okay, so if you are going to create any of the mates same as parts, it is going to give you an error and show you where the problem is. Okay, it's up to you to eventually solve. Okay, let's go back and start creating mates. Mate, this face, this face. I don't want coincident, I just want them parallel. So that I cannot orient it or rotate it. The second mate, we want this and this to be concentric. I can move up and down. I can change and then let's create this face. And this face, not concentric, but the next one is the distance. I want it at 1 inch. Okay, now I can move it up and down, left, right, but it is still not defined. Why? Anyone can guess it? What is missing?
Rotational.
It can still rotate. The rotational is not contained yet, and this is your indication. I can turn this, this pin, and you can see the hole is moving. Okay, so what do? Let's say create a mate by using this axis or face. So this axis, which is our hole, and made with, let's say mated with front plane. And it's coincident because they were right there, because we selected our origin. Now you cannot turn it, and you can see your negative side is gone. Yep.
Is it a must that they use front plane?
Sorry?
Is it a must we are going to use front plane?
No, you can, let's break that and do it again. Okay, let's do this, mate, axis, right plane, okay. So, or you can do it like this way. I would say, instead of plane, use an edge. Mate this to this edge. So we are selecting parallel or perpendicular. Because I cannot have coincident, because if I select coincident, that edge has to move there. It cannot, because we have so many other ways. So I can make it either parallel or perpendicular to that edge. Okay, so it depends on what your design intent is, what you want to do. Yeah.
So what we can do if there is no that small hole in that cylinder?
Then you go back to your roots, because every part has plates. Okay, so let's don't worry about this. Okay, so now let's say we do not have the hole. We still want to lock it, mate. Okay, let's do it this way. Mate, this face parallel to, so this is my pin. This is my top plane, right plane. Okay, this is parallel. So now I'm not assuming there is a hole. I'm using the planes to the face, and I can do it in an angle. Okay, let's say we want to pin into a special direction. I can use angles, distances, when it comes to two faces of features. Okay, there's no conditional requirement that plane has to match with the plane. Plane can match with an axis. Plane can mate with a face. Plane can mate with a hole. Plane can mate with, a view. Plane can mate with a body. Depends on what is your design. What is the lesson today is, what are the type of mates which are available for it? Okay, so we did one concentric or coincident, then face to distance, could be distance, parallel, perpendicular, angle, they are all available. Face to plane, they are all. So if you look at on the left, when you will select, two entities, you will have these options. Coincident, they exist at the same point. Parallel, everyone understand parallel? Perpendicular to each other, tangent to each other. Let's say we have a sphere which we want to attach with a square. You can select a face, or you can select the surface and the face and say they are tangent to each other. Okay? Then come the concentric, distance, or angle. Okay? Any questions? So coincident, parallel, perpendicular, tangent, concentric, Distance, we already talked about that. Angle, we looked at that. Okay, any questions? Okay, so very brief. Assembly, start with the assembly environment, bring in the base part first. Not fix it, align it. Okay, fixing is it can be anywhere. You want to align it with the origin of the assembly drawing. That's your goal first. Same as we were doing with the part, you want to tie your part with the origin. We want to tie the base with the origin. Yeah.
After we tie it to the origin, can we still rotate it?
If you say axis is aligned, no, it won't.
Okay.
If it's aligned to the origin
Yeah.
and you are aligning all the axes, it cannot rotate.
Cannot rotate. Okay,
Yeah.
understood. Okay.
Once you align it to the origin, it's fully defined.
Sorry?
Once you align to the origin, it will be fully defined.
It is fully defined. The base part. If you
Yeah, the base.
the base works if you align it to origin and say all the axes are aligned, it will be fully defined. But for the other parts, when you bring in, you have to make sure it does not move in any direction. So you need 6 degrees of freedom to be locked. Okay, any questions for me?
No.
Okay, so let's do this. Did you have all the parts downloaded? From eConestoga, download all the parts, open up your SolidWorks, and open up an assembly environment. Let's do some practice together. So new assembly. Okay, so you should have 1, 2, 3, 4, 5, at least 15 parts, 14 or 15 parts.
Professor, excuse me, how do we open them again without them being on the same?
As a new part,
Yeah, like different.
file, new, assembly, just like that. You're saying not bringing them in?
No, so when I try to insert a component, it would ask me to click somewhere here. So it would be on the same different parts.
You said without?
Yeah, so something like that. Something not in the same.
Or you just exit, Did you have, so this is the file I opened. There are a lot of files which are open, like I didn't say anything. Because it asks you to click on here,
Yeah.
you just exit.
Okay, got it.
Okay, you don't need to, it's helping you really by showing you all the parts, but if you do not want to pick one yet, just X the whole thing. Because it says begin assembly, you say I don't want to begin it yet. Okay? So,
Professor, it's not opening for me though, sorry.
it's not a click button.
Yeah. So I will try to right. And then
So you want to bring them all in?
Something like that, similar here. No, I don't want to.
So you want that?
Yeah.
Excellent.
Yeah.
So excellent. So new assembly. Okay. Cancel.
Okay. and
This
then-
is what you want? Or?
No, I wanted something like that. Like it would be on my tabs. Like your. So I want.
Oh, you want to see
Yeah.
all the parts?
Yeah, I want to see all the parts. Yeah.
Then go to you wherever you downloaded it. Select them all. So select them all. Say open. Okay, they are opening.
Okay.
So they are opening. Okay, and they will stay at the back. Okay. Now you open up a new file and say assembly. Okay, so you have 15 parts. So one way to open them all and keep them, with your under your tab, you select everything in the file folder and say open with the SolidWorks. Okay, they will all open and they will stay at the back. Okay, so you can easily access this. Okay, so I think. Okay, so this is what we are trying to make. Okay, these are all the parts which are given to us. This is your final. Is there a PDF drawing there? There must be a PDF drawing too. Okay, so this will be this type of this assignment you will get. So when you will get into your assignment, you will get a drawing like that. Okay? This is your final assembly drawing. You will have a list of parts and you will have to create an assembly from all the parts which will be given to you. Okay? And then you will start, exploded views and everything. And let's start doing it. So this is the part number 1. If you look at that, 8035W9P1 is your base. So you want to bring that part first in your assembly. Okay? So insert component. This is your base. Once you select it, you bring it in, and fortunately, it is in the right orientation. It is not, I would say, yes, we don't know where the exact orientation is, but it is okay. This is the way we wanted it. So if you look at, so I will drop it here, look at your PDF. This is the way it should sit. Okay, that's your base part. So because we are doing a bottom-up assembly, you want to bring in the first part, which is the base. So you bring it in and drop it there. Now, it is going to say it is fixed. Let's float it, and it's saying it's not fully defined. It's negative. Okay? So first thing we need to do is make it align to the origin in a proper orientation. Okay? So when I am doing an assembly, let's say we are building this assembly, where do you think the base will sit? It will on a top plane or a table. So let's look at how it's being assembled. I am a worker, how I'm assembling it. I put the base there, then I put the second part on top of it. So consider this your top plane. Okay? So let's mate it not directly to the origin, but going plane by plane. So mate top plane of the assembly to this face. Okay, so that now it's sitting on a table, which is my top plane. Yeah, and the face. So made. So we select the top plane of the assembly as my base. And then the second, we select this face, and I said coincident. So they are sitting, the base is sitting on the top plane of the assembly. And that's not a necessity. You can have it, you can say top plane is mating with the top plane. Let's see where the top plane is constructed for the part. Okay guys, can you pay attention here? So, top plane for that part is also right at the bottom. So it was constructed right. So you can do either top plane to top plane or top plane to the face. Okay? So let's do the top plane to the face. Always think like how the part will be assembled. It will be put on a table first. Top plane of my assembly table, face, coincident, it is there. Now I cannot move it up and down. Now it's a symmetrical part. You can see everything else is same. I think the holes will be same. It's a round part, it's symmetrical. So really, there's no binding that I want to, which way it needs to be locked in. What is that? Z and what plane? X plane. Okay, but I still want to lock it complete. So let's make the planes to the planes. So front plane of the assembly to the front plane of the part, and then right plane of the assembly or the base part to the right plane of the part. Leave them all coincident. Okay, now you can see my first face is fully defined, the base is fully defined, and it's locked in 3D space. Okay, everyone get that and are able to do it?
Front plane.
Right to right. Because those are the only features available really. Yeah. Oh, you want me to walk up there? You brought in everything. Why? Again, step by step. Bring one part at a time. Delete them all and bring only base. Yeah.
We can delete this.
Why? Oh, you can delete those features. Click on the mates. So your mates are, okay, let me show you so that everyone can see it. Okay, if you want to delete a mate and you want to recreate a mate. So the mates are always under the part. And it's made in assembly. So here's your 3 mates, coincident, top to face, coincident, front plane to front, right to right. If you want to delete it, right click and delete. Okay, they are available right under there, or they are available as a vague list right under the mates. Let's say if you have 300 mates, they all will show under this mate here. Part by part, they will be under every part. Okay, once my base is locked, let's look at our drawing. So this number 2, 8035W9P2 is the second part which should be in. Okay, so again, do not bring in all the parts at one time. It will be very, very hard to manage. Insert component, WP2, R. Okay, so I bring it in. So it is orientation is right, but if let's say the orientation isn't right, I could have turned it. It doesn't matter. This is wrong. So let's say you brought in part like that and you want to correct it. Okay, so this is the right orientation because we can still rotate it. So I will leave it there. Okay, and you can see the second part will never be fixed. It will always be negative. Yep. Select front plane of the assembly and then front plane of the part. Coincident. You must have done some other ways. Did you float it first? That's the thing. That's the first thing you have to make it float. This is fixed. That's why it cannot move. Now do it. Okay? So the step one, you have to make it floating, because when it comes in, it will be fixed. Okay? So step one, as soon as you're going to drop the first piece, it will be fixed. Break it, make it floating, and then you can mate it. Okay? Otherwise it's going to say, hey, it's already mated, you have to break some mates. Okay, so once the second part come in, if you look at this, it is axis to axis. So what do you think the best plan is here? Axis to axis. Okay, so visualize axis. I have this axis, I have this axis. Okay, made it axis, axis, coincident. Pretty good. It's already, SolidWorks is way smarter than us, I think. It knows what you need. So leave it there. And now it can go up and down, but it can rotate, but it cannot go away from that axis. How to make?
Access to access, how to make?
Visible?
No, like combine those two.
Okay. Okay, so these are the axes available. Again, it's all in mates. In assembly, all you will be doing mate, 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 mate. That's all. Okay? So click on mate, select this axis, and select this axis, and select coincident. Okay, now it can go up and down, it can rotate, but it cannot go away from that axis. Okay, now, okay, everyone have that axis mated? Everyone good or not yet? Is the axis visual? No? Click on the eye. Click on the eye and make them visible. So, right there under this eye, here's your temporary axis. Click on it. Okay? Then you go into mates and then select this axis and say coincident. Okay? Does it work? Okay, so now, if I look at the drawing, it sits here. Well, let's see what is the. Okay. So there is, if you look at the drawing, it seems like there is a distance or gap between these two faces. Right there and here. So what I'm looking at here, that it is something like that, but there's no dimension given between those two faces. Okay? There should be a dimension in that, so I don't know, there may be some, but let's say assume that it is staying maybe 2 inches, 1 inches, whatever it is. So make these two faces, the bottom face of this part and this part, at a distance of X number. So this is in inches. So now, mate, this face. So always use zoom, zoom, zoom. This face. And this face. The first thing is going to do coincident, but I don't want it coincident because there's a gap there. Okay, so let's say I wanted distance 2 inches or 1.5. So let's say 1.5 inches. Okay, so face of this part to the face of this part, make it 1.5 inches. Done? Okay, so now only one thing left is rotation. Okay, but if you look at it, it's a robotic arm welding. What do you think? This arm should be rotated or not?
It should be rotating.
It should be rotated because that's how the robot works. You know, you want to have the arm moving. Okay, that is the design intent. So I really do not want to lock it in this direction. Yeah.
If you give us this thing in a quiz,
With
for instance, if you give us this thing in a quiz, how do we know that the arm is not supposed to rotate?
you did get that? That's what
I
your question is?
understand. You know, you said it's a robot, it's supposed to be moving.
I am just assuming. That is the design intent. So let's say a robot arm is welding.
Yeah,
So what do you think? This arm should be moved.
yeah.
So that's why I do not want to restrict it this way. Okay? So now we have two components. This will be underdefined, but I leave it just because intention. Okay? So if I want to lock it, let's say we can lock it to one of the planes, right plane, and that's it, front plane. It is fully defined, but now I cannot move it. I think we are defeating the purpose of having a robotic arm. Okay? So deleting a made, last one, I'm deleting it because I want it moved. Okay, let's bring in the third component. Third component is number 3, W9P3, slider. Okay, so this component needs to ride on this bar here. So let's turn it, rotate it to Y, so that they are, kind of. Okay, so now if you look at these two parts, there is this little triangle bar on both sides. And if you look at this component here, there is a little slot there. Okay, this slot here. So what it means that this component is riding into this arm and sliding on these tapered faces. Okay, that's the design intent. So the first thing we can say it is coaxial. Okay, because it still has to move at the center to center. So let's again visualize the temporary axis. So make this axis to this axis. Okay, so I can move it in and out, but I can also rotate it. But the design intent is that it will not rotate because those two little tapered bars on both sides and the groove in this part is telling me that that's what the design intent is. Okay, so now what do you think we should be doing? How do we stop that from happening? plane. Is that the design intent? What is it?
We can select the face of the tapered face and make it coincident with the face
With
of
the slot. Okay, because if you look at the design, we do not want to restrict it to the planes. We want to slide it on this face, which means these faces to be coincident. Okay, so let's select that. Okay, mate this face. And now it will be a little hard part come in. Zoom in and this top face. Okay, these are parallel. Okay, it's not be coincident. Now you cannot rotate it because it's locked with those guides. And if you look at the so if you look at these planes are mated together and it can slide in and out, but it cannot rotate. And that is our design intent. Okay, but it still can go too far. Okay, so what do we need to do? We need to control the distance between this and this. Okay, so let's make this so that it can only go up to here and there. Okay, so mate.
Professor, sorry, can you please repeat the last name?
The last one?
Yeah, yeah.
It is just a face-to-face parallel.
Face to face.
Yeah, so one of the top face in that bar or the sliding bar made with the top face of the groove. And then it won't rotate. Okay? So now if we look at this mate here, okay, we are going into a little bit of advanced, but I still want to give you that information. So when we go into the advanced, you have center, symmetric, path, all the high-end mates. We don't need it, but we can use this one here, minimum distance and maximum distance. Okay, so we can make those two faces together. Face 1 and face 2. So if you look at, this is the minimum distance. Okay, so this is minimum distance. Let's make it 0. Okay, so if I made the minimum distance 0, and these are under advanced. This won't be part of our course, but I still want you to look at it and see how to use it. So we want to control this movement from there. So we want to control this movement between this face and this face. Okay, so in this case we can use advanced with the distance, linear distance, minimum 0 and maximum, I don't know, let's make it 2. Oh. We already have it. Now you can see it cannot go past that and it cannot go farther than 2 inches. Okay, if you can't do that, just make it, okay, a distance from A face. Okay, everyone up to this point?
Sir, can you
Sorry?
You see the minimum, is it advanced?
It is in advanced. Okay, just do this one. Okay, don't go to advanced. Let me go back. I screwed up a little bit. I did it twice. Okay, do this. Make this distance. I don't want to go in advanced because standard. This face and this face, not coincident, but distance. Let's make it 1.5 inch. Okay, just do that. Don't go into advanced. Yeah, fancy, but we don't need it. Don't get confused. Okay? Just create the distance between a face and this face to a certain number. Okay, now I cannot move it. This can still rotate. I cannot rotate it. It's locked. So my design intent is pretty much okay. Now we want the part number 4, small arm. Okay, everyone up to this point? Yes, no?
Yeah.
Everyone get that? That third one? No? What's not happening? You should sit closer then. You really want to get to you. Select the faces. This face. This face. And then say this face. And numbers. No, not 0. Zero, you don't need 0. You can coincident. You can, but we already did. That was the first time, but it's still going to rotate. So to stop that rotation, you need another, which is your design intent of those wedges. You can make the plane so that it won't rotate. What is happening? Did you fix it? Why is it not rotating? Well, you fixed it? Okay. This is fixed too. Why? Why did you fix it? Okay, when you ask it. Okay. Made. X's. Yeah, it's done. It's okay. Okay, now make this face, this top face. There's a wedge there. That's why you need to zoom better. Okay, make this face. Select this face. Made. There's a groove inside. No, you can do either way. You can go to make first and then select the face. Now you zoom in, look for that face, make sure it's top. Turn. In the top face. Okay, so let's bring in the third part, or fourth. Insert component, part number 4, bring it in, it's pretty straight, so it is good. Leave it there, make axis to axis. Okay, and how does it fit? Oh, it doesn't say anything how far it is, but let's do. So it must sit here somehow.
You can make a tangent to the rotating rod.
Yeah, but there's no space there. Like the depth is not enough there. Cannot go down. Okay, so I don't know what the dimensions are. Let's make it, because this is only. Okay, so make this face to this face, not coincident, but distance, just to keep the design intact. I don't know what that numbers are. Go a little bit farther. It's right into the arm now.
Sir,
Yeah.
you can make bottom face of the pin to
Yeah, we can make that. This face,
tangent to the circular
this
face.
circle, make it tangent. Okay, so it's still rotating. I don't know what the intent is, but leave it there. Bring in 5. Lock. Okay, everyone is up to here? Everyone is up to here?
No, sir.
You can make a tangent. Okay, do this instead of distance. So let's do this. I will delete this and show you how. Like, because it's a pin, it cannot go farther than this point. So let's make those two tangent to each other. So the bottom of this pin, select the bottom face, and then select this pin anywhere, and it's automatically be tangent because that's the only option really you can use. Okay, make it tangent so that it sticks to it. So now it cannot go up, it can still rotate, but it will stay with it. Okay, once it's done, the top block, make the faces to this face, concentric, or you can use axis too, or coincident by using axis. Let's do that concentric and make this face to this face so that it sits on top. Okay, it's still rotating. The drawing doesn't call for anything. The instructions to do it all are available on page 6 to 76. This must be from your textbook. Okay, everyone up to this point? They brought the block in. The block in.
It's okay. Is it good?
Yeah.
No. Yeah, just click. Click.
Okay, after the block, we are going to bring in the part number 6, which is the fixture. Okay. Bring in the fixture, and now, if you look at the drawing, if you look at the drawing, this fixture is bolted to the block, and these faces are parallel to this face here. Okay? So let's make the faces first. So the bottom face is sitting on here. Or, well, let's do the parallel first. So this face. Oh. Okay, now we have to make the bolts. So if you look at these bolt holes, 1, 2, 3, these are mating with bolt holes 1, 2, and 3. Okay, so let's make them axes. First one, so it can still rotate. Second. Okay, so now it cannot move. And the last one, this face to this face. Okay, so the block should move relative to the fixture. Everyone get that? So for the fixture, line up these holes. There are 3 holes. Make those holes and the face. Make just 2 holes and a face, and that will be fine. That's all you need.
Sir, please, which holes are you making?
These 3 holes. 1, 2, 3.
Any one of them or the 3 of them?
No, you have to, okay, let me, okay, you need to make those 2, at least 2. So make sure you select the right one. So this one to this one. Okay, these two holes made this to this axis. Okay, then this to this. Get that? These two holes to these two holes. Okay?
What about the third one?
Third one you don't need it really, because once the two bolts are there, it can't change. Okay, you can make the third one too. These two are minimum. These two, and then make the faces. So that it will sit on top of each other. Mate, and mate. Okay, bring in the bolts, number 12. There are 3 bolts. Okay, so I brought in 1 bolt. It's hex AI, hex 2 AI. So now we need to change the orientation. So mover triad. Okay. So now mate the face with this. And it needs to be tightened. So face. To the face. Okay, you can use either axis or the faces to be concentric. It's still turn. Copy, drag, 1, 2. Made face with this and face same goes for the third one.
There are 2 80s. Okay, 2. I don't understand. Is this PP?
Okay,
Screw P.
everyone up to the bolts?
X screw P.
Or is everyone too tired now? Okay, so wherever you are, so I would say when you go home, keep working on it. Now you know the basics. Any questions for me for that? We're almost 7:45. Okay, so keep practicing, finish the assembly, bring your assemblies back to the next class, okay? Make sure you, when you come in, you have completed your assembly, and if you have any questions, we will talk about it. Before you go, let's see how to save the assemblies. The first way is to, let's say file, save as. I am just saying assembly 5. And you see there's include all reference components. Because you do not just want to save the assembly. You want to save all the parts which are part of that assembly. So click on that, include all reference components, save. Okay, make sure whenever you say save the assembly, especially the first time, you always say include, save all reference components. Because then it automatically is going to keep updating and saving all the components if you make any changes. Okay? So that is really,
Sir. Sir.
yeah. Okay, hold the face. Do more. To the top face. No, not that face. If you are in, then select the bolt face. Let go. So when you are making it concentric, you are selecting this face, not that, not the head face. Then you select this face. Escape. And concentric. Okay. Now you select this face and then bottom face, so that it will line up with the faces. Okay, if any questions?
Could you upload that video?